Hi, welcome to everyone. I'm Alberto and here I'm presenting you circFA, a project that together with Francesco and Enrico I'm working on for the Xilinx Open Hardware contest. Let's start with talking about Victor. After filling an article in his throat for about a month, Victor decided to visit the University of Chicago Medicine campus for a checkup. It had only been a quick tickle that caused him to clear his throat more often than usual, but he wanted to be sure that his health remained stable. The doctors proceeded through some exams and identified that what was affecting Victor was a lung cancer in an advanced state, and so they started chemotherapy immediately. Although the doctors identified what was affecting Victor, they couldn't identify a single cause of his disease at first, and this, combined with the advanced state of the cancer, would have left Victor with little time to live. They decided to make Victor do a very specific test on a very particular mutation of lung cancer that they were studying at the campus. And lucky for Victor, it was the same that affected him. The researchers have also already developed an experimental drug to block this specific mutation of lung cancer to extend further. Victor started taking this drug immediately, and because of this, he's still alive today. Victor's case was very peculiar, because researchers already had something very specific to compare with his disease, and because of this they identified it. This means also that if the mutation of Victor's cancer would have been different, he probably wouldn't survive. Recent discoveries showed that circular RNAs are correlated with many types of carcinogenesis and CNS pathologies, and therefore that they can be used to diagnose very specific diseases, like in Victor's case, but this time on a much larger scale. To identify the presence of circular RNAs in the organism, we have to align sequences of the genome with sequences of the circular RNAs. This means that we have to compare these two sequences and see if one coming from a circular RNA corresponds with part of the genome. If this is true, we have then what is called an alignment. This process is done by computing a matrix which shows where the two strings matches and also the particular path on where they do. The problem is that this process is very slow and that we'll have to analyze the data of a lot of people in order to provide a custom solution for as many of those that need them. We are also missing information regarding circular RNAs, which means that they could also be involved in many other pathologies that we currently do not know. Here is where our application comes into play. Our solution is to accelerate the identification pipeline of circular RNAs by developing circFA, which implements the slowest part of the pipeline, which is the alignment phase, on FPGA. We are focusing on integrating circFA with botai2, the core aligner of most DNA aligners, and most importantly for our case, it is the core aligner of TOPET2, which produces the best results in terms of circular RNA alignment, and also because its output can be passed through the tool circExplorer2, which is essential to mark the circular RNAs that have been identified. Therefore, the FPGA acceleration of the alignment will permit to provide tailored therapies for many patients in reduced time, and also to create new databases that will have more information about the circular RNA role in various pathologies. Thank you for your attention. If you are interested in our project, you can contact us directly, or you can also follow us on social media. See you next time for more details about circFA.